Okay, as I'm continuing with section 7.1, we're asked to approximate this to the nearest thousandth, the cube root of 15. What times what times what gives me 15? Notice the minute it says approximate, we need to put this sign, not equals, because we're not giving an exact answer, we're giving an answer that's close to the exact answer, okay? So, I take my calculator, my graphing one in this case, I hit the math menu. I pick option, let's see if you can see it, I pick option 4, which is the cube root option, and I type in the number, 15. Close parens, hit enter. So my answer comes out to be 2.46621. Okay, they asked me to the answer to the nearest thousandth, so what I do is I have to write 2.46, and then notice the 6 on the calculator, there's a 2 that comes after it. If that was a 5, 6, 7, 8, or 9 that came after it, I would round it up, but since it's a 2, I just ignore it, so my answer is approximately 2.466. And we're done. Okay. Find the principal square root of the following. Assume variables can represent any real number. Now, what they mean by these directions is variables can be positive or negative. Well, remember what we talked about earlier? First of all, when you don't see the number in the pocket, you assume it to be a 2. And there's another thing we talked about. When you're taking the square root of a number, the answer has to come out to be positive. Now, a lot of times my students, when they're doing this problem, here's what they'll do. They say the square root of 36 is 6. Okay? And then here's another little trick. You might as well need to learn it's really not a trick, it's the truth. When you take 2 and divide it by 2, you get 1. So that puts x to the first power as my answer. Now, 6x times 6x would give me 36x squared. But the reason this answer is not completely correct, remember when you have a square root, answers have to be positive. Well, in this problem it said variables might be negative. I can't leave x in my answer because that could be a negative number. So the way I correct it is by putting absolute value bars on it. So the correct answer to this problem is 6 times the absolute value of x. Here's the next problem. The 6th root of y to the 6th. Whenever the index is even, my answer has to be positive. Okay, when it's an exponent, you divide the index into it. 6 divided by 6 is 1, so I'm left with y to the first power. But there's a problem. Y, I can't tell whether that's positive or negative, and it's required to be a positive answer. So the way to make that happen is by slapping absolute value bars on it. All right. Okay. Find and evaluate the 4th root of 625. 4th root. Okay? The way I do this on my graphing calculator, I type in the index first, which is a 4. Then I go to the math menu and I pick option 5, which basically says the root. So 4th root of, and then we type in 625 and we hit enter, and the answer is 5. Now again, remember what I told you. Your calculator may not be a graphing calculator, and you're either going to have to read the directions in your manual, ask your teacher, or go to the math learning the Learning Commons, where they will help you learn your particular calculator. The 7th root of -1. We don't even need a calculator for this. What number multiplied by itself 7 times would give you a -1? Well, pretty much without doing much thinking. The answer has to be negative, because if this is an odd index, to get a negative answer it has to be negative. Negative 1 multiplied by itself 7 times would be negative 1. So, last thing on this movie. Write the following using radical notation. One of the things you need to know. Fractional powers become radicals. That's the definition. The denominator becomes the index, and the numerator becomes the power of the variable. So, if I'm rewriting x to the 1/3 power, I put a radical sign. X goes under the radical. 3 becomes my index, and 1 becomes my power on the x. So x to the 1/3 power is really the cube root of x. Anytime you see fractional powers, you are seeing radicals.